In this video, we are going to talk about implicit differentiation. Let's say we have a function y is equal to f of x, where y is dependent variable and x is independent variable. Since y is dependent variable and x is independent variable, so we find the derivative of dependent variable with respect to independent variable x. And on the right hand side, we have f dash x. For example, we have an expression y equal to x square. This is an explicit expression because y depends upon x and the terms involving x is entirely on one side. So when we find the derivative here with respect to independent variable, which is x, we get derivative of y with respect to x, and the derivative of x square with respect to x is 2x. Let's look at another explicit expression. We have y equal to x plus 1. Here y depends upon x explicitly, meaning that on one side there are terms involving x. So when we have to find a derivative with respect to independent variable, which is x, so we write differentiate with respect to x. So derivative of y with respect to x, we write it as dy by dx. Derivative of x with respect to x is 1 by power rule, and derivative of a constant with respect to x is 0. So our answer is 1. Now let's say we have another explicit expression, means y depends upon x and the terms involving x are entirely on one side. So when we find the derivative of y with respect to x, on the right hand side by the power rule, we get 3x square plus 2x minus 0, which is equal to 3x square plus 2x. Now if we have an expression like this, and we know that y is dependent variable and x is independent variable. So this kind of expression where y is not written explicitly in the form of x is called implicit expression. This expression is written in the mix of both variables x and y, where x is independent variable and y is dependent variable. So for this expression, if the question is to find dy by dx, then for this implicit expression, finding the derivative dy by dx is called implicit differentiation. So let's attempt a question. We have an expression xy square minus 2y plus 1 equal to 0. This is an implicit expression and the question is to find dy by dx. So to find the derivative in this case, what you will do is to write this whole expression as it is. Since we have to find dy by dx, where the upper variable y is dependent variable and the lower variable x is the independent variable, so we will have to differentiate this expression with respect to x. Let's differentiate this expression with respect to x. Now see this term. This term is written as the product of two terms x and y square. Whenever two terms are being multiplied, to find the derivative, we will have to apply the product rule. So for this term, the derivative would be by product rule, first term as it is, derivative of y square with respect to x. Now y square, its derivative by power rule would be 2y 2 minus 1 and the inside term derivative with respect to x, which is dy by dx. So let's write here first term as it is and the second term derivative, which is 2y dy by dx plus first term derivative. First term here is x. Derivative of x with respect to x is 1 and the second term as it is. Minus 2 derivative of y with respect to x. Derivative of y with respect to x plus derivative of a constant. Here constant is 1. Its derivative is 0. Equal to derivative of 0 is 0. Let's simplify this expression. 2xy dy by dx plus y square minus 2 dy by dx. Since our question is to find dy by dx, so we will combine the terms having dy by dx. 2xy minus 2 and let's take dy by dx as common. And y square goes over there with the change of sign. We are trying to find dy by dx. So we get minus y square whole divided by 2xy minus 2. So this dy by dx is called the implicit derivative for this expression xy square minus 2y plus 1 equal to 0. This is how we attempt the implicit differentiation questions. Let's look at the question. We have to find the derivative of x square y plus 5x plus 7 equal to 0 and the question is to find dy by dx, which tells us that we have to differentiate the expression with respect to x. Let's find the derivative here. First we will write the expression as it is. So we have to differentiate this expression with respect to x. Now for the first term, since it is written as a product of x square and y, so we will apply the product rule of derivative. First term as it is, derivative of the second term with respect to x. Second term is y, so derivative of y with respect to x plus derivative of the first term. First term is x square, so its derivative with respect to x is 2x. And the second term as it is plus 5. Derivative of x with respect to x is 1 plus derivative of 7 with respect to x. 7 is the constant, its derivative is 0 and derivative of 0 is 0. So we have x square dy by dx plus 2xy plus 5 equal to 0. Since we are trying to find dy by dx here, so we will keep the term having dy by dx on one side, everything else on another side. It gives us minus 2xy minus 5 whole divided by x square. So this is how we find implicit differentiation of the given expression x square y plus 5x plus 7 equal to 0. Let's find the implicit differentiation of another expression, which is y cosecant x plus 7x cube plus 3y equal to 0. And we have to find dy by dx, which tells us that we have to differentiate this expression with respect to x. Let's write this expression again, which is y cosecant x plus 7x cube plus 3y equal to 0. We will differentiate this expression with respect to x. Since the first term is the product of y and cosecant x, that is, it is the product of two terms. So to find the derivative of y cosecant x, we will apply the power rule of derivative, which says first term as it is, derivative of cosecant x with respect to x. Cosecant x derivative is minus cosecant x cot x plus first term derivative with respect to x and second term as it is. First term here is y, so its derivative with respect to x is dy by dx and second term as it is plus 7. Derivative of x cube with respect to x is 3x square plus 3 into derivative of y with respect to x, which is dy by dx equal to 0. Let's simplify this expression. Minus y cosecant x cot x plus dy by dx cosecant x 7 3 to 21 x square plus 3 dy by dx equal to 0. Since we have to find dy by dx, so we will combine the terms having dy by dx in it, which gives us dy by dx is common and we have cosecant x plus 3. And the terms which don't have dy by dx, we will take those terms on another side. So we have y cosecant x cot x minus 21x square. Let's find dy by dx from here. We have dy by dx is equal to y cosecant x cot x minus 21x square whole divided by cosecant x plus 3. Please see that when we have an explicit expression as y entirely depending upon x, in that case when we find the derivative of y with respect to x, on the right hand side there is the expression only involving the x terms. But in implicit differentiation, as you can see here, dy by dx on the right hand side involves both x and y terms. So this is how we find the implicit differentiation.